Hi guys, so we're going to graph polynomial functions. We worked with them yesterday, and today we're going to graph them, see what they look like. A couple things you need to know for sure. If a polynomial function has degree n, whatever the degree is, it tells you two things. First of all, it tells you there's at most that many real zeros, which means there's at most that many x-intercepts. So if the degree is 3, it can have at most 3 x-intercepts. It may not have 3, but it can have at most 3. Also, it can have at most n minus 1 turning points. So if the degree is 3, it can have at the most 2 turning points, meaning degree 3 may look like this, like it may do something like that, or if you look at that, there's a turning point, it's also a max and a min, and there's a zeros, 1, 2, 3 zeros. So at most 3 zeros, at most 2 turning points. It may not have that many, but it has at most that many. That's going to help us as we graph. All right, here's one just to graph. When we graph these things, I'm going to pretty much find the same thing every time. I'm going to try to find the x-intercepts, which are the zeros. I'm going to try to find the y-intercepts. And then based on what we did yesterday, I know what the n's doing. Okay, so what I know first of all is the degree is even because it's degree 4. And because it's degree 4, that means the n's do the same thing. And because it's negative, both ends are going down. So it's going to do this on one end and then on the other end for sure. So I know what the n's are doing. The x-intercept, you just kind of solve it for 0. So I'm going to act like it says it's equals 0. I'm going to solve this thing, which means I'm going to try to factor it. If I factor it, I can take out an x cubed. That will leave a negative 2x plus 3, which means my two x-intercepts or zeros would be 0 because of right there, and it has multiplicity 3. And the other one would be 3 halves, and that comes from right there. And if you don't know those, you can set them equal to 0 and figure them out. So my x-intercepts is 0 and 3 halves. That's helpful. My y-intercept, your y-intercept is, the way you find the y-intercept is you plug 0 in for the x's, right? When you do that, there's nothing left, so my y-intercept is also 0, obviously. If the x-intercept is 0, that's the origin, so the y-intercept is also 0. So if I start to graph this, I'm going to put my x-intercepts on my graph. One is at 0, the other one is at 3 halves, which is 1.5, which is right there. So I know it crosses the x-axis there. I know the ends are both going down, so I'm thinking my graph is going to do something like this. It's going to go up. It has to go through that one. It's going to go up here. It's going to come back down. It's going to be similar. That may not be exactly what it looks like. And you can punch in your calculator to make sure and kind of double check it. But it's going to look something to that effect. And that's kind of what we're going for today, is kind of a general graph of what the polynomial functions look like. Okay, here's our steps. When to graph it, we're going to use a leading term test. That means we're going to find out if it's even or odd and positive or negative. Kind of tells you what the ends are doing. Number 2, we're going to find the zeros, which are x-intercepts, which means I'm going to solve it. I'm going to say f of x is 0, solve it, and see if I can find out where the x-intercepts are. Number 3, I'm going to use those x-intercepts to divide the x-axis into intervals, which is what I did. Choose a test point. I didn't do that a second ago because I knew it had to go up between the two. And that will tell me kind of where it's going in between the two. Find f of 0, which means plug in 0. That tells you the y-intercept. If necessary, find additional values to determine the general shape. Now, if we do that, what we will do is we'll probably use our table function on our calculator. And it says as a partial check, use the facts, you can just kind of check it. It should have at most n x the degree intercepts and 1 minus that for turning points. Multiplicity also be considered because remember the graph is tangent to it or bounces off the x-axis, and if it's odd, it actually passes through the x-axis. Okay, let's try another one here. What I did on this one, there's the original function. I went ahead and just factored it for you. And the only way to factor 4 terms, remember, is factor by grouping. So I grouped the first 2, and I got that. I grouped the second 2, grouped the second 2 and got that. I took the 2x plus 1 out, gave me that. That left me x squared minus 4, so I got that. So quite a bit of info right there. When I start to graph it, I'm just going to talk you through this one. My x-intercepts are all my zeros. Like what makes the parentheses 0 up there? So I'm looking at all 3 parentheses, all 3 factors to try to figure out what makes them 0. Now the first one would be negative 1/2. So I'm putting a point there, negative 1/2. The second one is negative 2. The third one is positive 2. And I got those just from finding out what makes my factors become 0. All right, now I do know it's odd and it's positive. Odd positive goes down left, up right. So I know from here it's going to go down this way, and from here it's going to go up that way for sure. So what that tells me it's going to do is the general shape is going to go above here, back down, and then back up through there. And again, you can punch in your calculator to kind of check what the graph looks like, but that's the kind of info I'll be asking you for in your assignment and also on your test coming up. All right, another one, graph this one. I'm going to do it the exact same way. I'm going to go ahead and draw my graph down here, and I've already factored. I went ahead and factored it for you. Make it a little bit easier for us, because once it's factored out, once it's in this form, it's not that bad. So find the zeros first. Remember, the zeros are what makes your parentheses or your factors 0. So the first one is -1, putting it there. Second one is 2, and this 2, that one's squared, which means the multiplicity is 2, which means the graph's going to bounce or be tangent right there instead of passing all the way 3. And the third one is 4. The other thing I forgot to do last time is my y-intercept. My y-intercept is -16, which is way down here. So that's way, I didn't draw it nearly far enough to get to -16. So I'm going to say, that's -16 way down there. So I know I'm going to have a point right there. And that is helpful when I draw these things. So now I'm looking at end behavior. It's degree 4, which is even. It's positive, so both ends are going up. So I know this is going to happen. I know it's going up from here. I know it's going up from there. So my graph's going to do this kind of thing. It's going to go way down here, -16. It's going to come up to the 2, but when it gets to the 2, because it's squared, has multiplicity 2, it just bounces. It goes down, doesn't actually go through, then goes back up like that. Now I'm just estimating here how far down that went right there. But here's what I know. The degree was 4. The degree is 4, which means it can have 3 turning points, and it did. There's one there, one there, one there. It can have at most 4 zeros. This one really had 4. You only see 3 because one of them counts twice. The 2 counts twice. So and that's kind of how we're going to go with the graphs today. All right, intermediate value theorem is really, let's just read it real quick. To find out where zeros are, this is really used a lot more in the past than we use today, to be honest with you, because we have calculators today which help us so much. For a polynomial function with real coefficients and a does not equal b, if you plug in a and plug in b and you get opposite signs, that means there's a 0 between a and b. It cannot be determined whether there's a real 0 between a and b if they have the same sign. So if you plug in one number and you get a positive and plug in another number and get a negative, that means the graph crosses the x-axis between those two. And when we're doing intermediate value theorems tomorrow, we're going to use the table function on the calculator. And it's much easier for me to show you that than it is to video it for you. So we'll work on that in class tomorrow. So make sure you bring your calculator with you tomorrow. And that's it. I'll see you then.